In the blockchain world, the concept of an account is pivotal, serving as the gateway for users to interact with the network. An account on a blockchain typically includes a wallet address, private and public keys, and often mnemonic phrases for recovery. These elements ensure secure transactions and ownership of digital assets. Ensuring seamless and secure account-related functionalities is crucial for the user experience of any decentralized application, DApp. As a DApp developer, understanding how these account functions are designed across different blockchain protocols is essential. In this article, we will delve into the account-related functions provided by several major blockchain platforms: Bitcoin, BTC, Ethereum, ETH, Solana, SOL, Arbitrum, ARB, and Aptos, and how these functions are accessed and managed through their respective software development kits, SDKs. Account-related functions in blockchain protocols: Bitcoin, BTC. In Bitcoin, an account is associated with a pair of keys, public and private, and addresses derived from the public key. The Bitcoin SDKs like Bitcoinj provide functionality for address generation, key pair creation, and signing transactions. However, Bitcoin does not natively support mnemonic phrases in the protocol, and this functionality is typically added by wallet applications. Ethereum, ETH. Ethereum accounts come in two flavors: externally owned accounts, OAs, controlled by private keys, and contract accounts, governed by smart contract code. Tools such as Web3.js and Ethers.js in Ethereum's SDK provide extensive account management features including key pair generation, address derivation, transaction signing, and mnemonic phrase generation and recovery. Solana, SOL. Solana supports a high-performance blockchain with a different structure for accounts, which can hold both SOL tokens and data for smart contracts. The Solana SDK, Solana Web3.js, allows developers to create key pairs, sign and send transactions, and manage account data. Mnemonics are also supported for easy recovery of accounts. Arbitrum, ARB. Arbitrum, being an L2 solution atop Ethereum, follows Ethereum's account design. Consequently, the Arbitrum SDK extends the use of Ethereum's account functionalities, inheriting features like OAs, transaction signing, and mnemonics. With Arbitrum, developers focus on scalability and cost efficiency, while the underlying account structures remain consistent with Ethereum. Aptos, a newer blockchain, uses the Move language, emphasizing safety and flexibility. The Aptos SDK includes functionalities for generating and managing keys, addresses, and executing transactions akin to other blockchains, with additional security measures at its core. Account recovery using mnemonics is also part of the Aptos account model, maintaining the industry standard for user account recovery. Comparison and analysis. When comparing the account management features of these blockchain protocols, there are several factors to consider regarding their SDK design and functionality. 1. Key management. All platforms support the generation and management of private and public keys, which are fundamental to blockchain interactions. 2. Address derivation. Address generation is a common feature across all SDKs, although the methods of derivation can differ depending on the cryptographic algorithms used by each blockchain. 3. Transaction signing. Signing transactions is a universal necessity. Every SDK offers this capability, but with different levels of abstraction and tools available to the developer. 4. Mnemonic support. Most modern blockchains and their SDKs provide mnemonic support to assist users in managing their private keys securely and conveniently. 5. Ease of use. Ethereum-based platforms, including Arbitrum, benefit from a mature ecosystem with extensive documentation and community support. Solana's distinct design for accounts requires some learning curve but offers extensive documentation. Aptos, being newer, poses a new set of APIs and requires learning the Move programming language, potentially raising the barrier to entry but promising enhanced security. 6. Flexibility and security. Aptos arguably emphasizes security more in its account model with the Move language. In contrast, blockchains like Ethereum have a broader focus on functionality and compatibility. In summary, while the core functionalities such as key pair generation, address creation, and transaction signing are available across all platforms, differences arise in the implementation details and auxiliary features of each blockchain's SDK. dApp developers must decide on a platform by weighing factors like native SDK capabilities, security features, and the ease of use of account-related functions. Whether one prioritizes the simplicity and proven security of Bitcoin, the extensive features of Ethereum and its L2 solutions, the high-performance capabilities of Solana, or the fresh and security-oriented approach of Aptos, depends on the specific requirements and goals of their dApp project. This chapter introduces how to generate wallet addresses and corresponding account information such as private keys, public keys, mnemonics, etc. SDK interface intro and the official SDK. There are mainly the following methods and account information related methods. Generate those address used in SDK methods are as follows. The following is a complete wallet generation function in Java. Generate a private key file named after the wallet address. Generate file name 1ZIA5ERG9C9K7RQGJ9RXSXXXX.private, and the private key file content is as follows. Developers who provide code snippets integrate C/C++ code into Java programs through JNI. The developer packaged and renamed the methods in C. Please refer to relevant documents for specific usage and precautions of JNI. Generate mnemonic words. Export the corresponding private key handler based on the address named private key file. After obtaining P, use the export _mnemonic_ from _prikey_ handler method to get mnemonics. Java code encapsulation method. Generative address is used for interface calls related to smart contracts. Java code encapsulation method. As dApp developers explore new horizons with emerging blockchain technologies, it's critical to scrutinize the account-related functions provided. The hypothetical transformers chain, with its novel features and unique approach to digital identities, offers a broad spectrum of functionalities for developers to incorporate into their dApps. This article discusses the essential considerations dApp developers must account for when utilizing the account functions within Transformers Chain's development environment. Managing account-related functions is an area that demands mindful consideration from dApp developers, with security, usability, and compliance at the forefront. When it comes to the Transformers chain, a detailed understanding of the SDK's offerings around account management, adaptability to its unique mechanisms, and vigilant security practices will define the success of a dApp. By focusing on these essential aspects, developers can forge a robust foundation for users to securely interact with the next generation of blockchain applications, ensuring a secure, efficient, and user-friendly experience on the Transformers chain.